This is one of a series of videos produced by the Further Mathematics Support Program for A-Level Online Revision. In this video I'm looking at the AQA D2 specification, and it's question 4 from the January 2011 paper. Well, as soon as we see the question we recognize that this is going to be a simplex problem. And in fact we're told that we're to use the simplex method to maximize a profit equation P equals 3x plus 2y plus z, subject to the constraints that are given there. And it says that the initial tableau is given in this particular table. In part A, the question, we're to use the pivot from the x column and to identify the pivot, explaining why this particular value is chosen. We're then to use one iteration of the simplex method and explain how you know that the optimum value has not been reached. Following that, one further iteration and then interpreting the final tableau. So this is a fairly standard sort of question for simplex. We're told to choose the x column. We've been told that because the x value is negative 3 is the most negative value that we have in that first row. So choosing that as our pivot column, we now need to calculate what are sometimes referred to as the theta values by taking the value at the end of each row and dividing by the number which is in the x column. So 4 divided by negative 1, giving us negative 4, 10 divided by 2, and 21 divided by 4 is 5 1/4. And we want the smallest positive value. It must be positive, so the smallest positive value here is 5, and that gives us the pivot as being the 2. So it says the first pivot from the x column, the pivot is equal to 2, and it's because that 5 is the smallest positive theta value. So 2 marks for that part of the question, a B mark for obtaining the actual pivot as being 2, and then an E mark for the explanation of that. The second part then of A is to do simplex iteration once. Okay, so this is the pivot column, and so we want to arrange for the pivot to become 1. So the first thing we need to do then is to divide that row. I'm going to number the rows: row 1, row 2, row 3, and row 4. So we're going to first of all divide row 3 by 2, giving us 0, 1, 1/2, 2, 0, 1/2, 0, and 5. And then by a series of additions or subtractions of the rows, we want these other values in the pivot column to become 0. So if we take row 1 to start off with, at the moment there's negative 3 there. It's probably easiest to use the row closest to it. You can either use this row here for adding, or you could use this new row here. It doesn't really matter which, but it's probably easier to use the row in the top table because it's just easier for your eye to see the numbers. So I'm going to do in here row 1, and I need to add on to that row 1 1.5 times row 3. So we're looking from this row to this row and adding 1.5 times row 3 onto row 1. So that becomes 1. 0 obviously in the x position, because that's what we want it to be. And then we get negative 1/2. 1.5 of 4 is 6, so that's going to give me a total of 5. That will be 0. 1.5 times 1 is 1.5. 3/2 if you wish. 0 here, and then 1.5 times 10 is 15. And there we are, completed. For row 2, we need to take half of row 3 and add it on. So we're going to do row 2 plus 1/2, or 0.5, times row 3. And if you do that, you get 0. 1.5 here. 1/2 of 4 is 2, so that gives me 3 there. 1, 1/2, 0. 1/2 of 10 is 5, so in total now 9. For row 4, we need to subtract 2 lots of row 3. So this is going to be row 4 minus 2 lots of row 3. And if we do that, we get 0, 0, and 0, and then 2 lots of 4 is 8, so subtracting that from 3 gives us negative 5. Continuing along, 0, negative 2, 1, and then let's take 2 lots of 10 is 20, subtracting that from 21 gives us finally 1. So that's the first iteration completed. It says we also need to say, explain how you know that the optimum value has not been reached. Well, we simply need to say that it's not optimal as there's a negative value in this first row. So the negative value of negative 1/2 there. Okay, the marking for that went as follows. There was a method mark for doing row operations, and then A marks for each of these, so up to 3, so A1, A1, and finally A1. So for 1 correct, 2 correct, or all correct. And then a mark here, an explanation mark for saying why you knew it's not an optimal value. In part B of the question, we're asked to do one further iteration. So our pivot column is now the Y column because it's got that negative value. So we now need to do some divisions. 9 divided by 3/2 is 6. 5 divided by 1/2 is equal to 10. And 1 divided by 0, well, it's undefined, I suppose, so you could think of it as being infinite if you like, but the smallest positive value is given by the 6. So that gives us a pivot here equal to 3/2. So we need to make that equal to 1. So if I again call these row 1, row 2, row 3, and row 4, I'm going to do here row 2 divided by 3/2, multiplied by 2/3 if you wish. But that will become 0, 0, 1. 2/3 of 3 is 2. Then we get 2/3. 2/3 of 1/2 is 1/3. 0 and 2/3 of 9, 6. We've now got to make these others in column Y all equal to 0 by adding values of row 2, or subtracting. So if we look at row 1, we've got there negative 1/2, So if we add 1/3 of row 2 to that, so we do row 1 plus 1/3 of row 2, so that's in there. 1/3 of that will be adding a half, which give us 0. So that's going to produce 1 and 0 to start off with. Then 1/3 of 3 is 1, obviously, so 5 plus 1 is 6. That becomes 1/3. A little bit trickier here. 1/3 of a half is 1/6, and then we've got in total there 9/6. So 3/2 is 9/6. So in total 10/6 or 5/3. A little bit of arithmetic there with fractions. Let's do that again. 1/3 of a half is 1/6. 3/2 is the same as 9/6, so that's 10/6, which cancels down to 5/3. 0 here. 1/3 of 9 is 3. 3 onto 15 gives us 18. If we now look at this one here, we're going to have to this time subtract 1/3. So they've made the arithmetic reasonably okay for us. So this is going to be row 3 minus 1/3 of row 2. And that will give us therefore 0, 1, 0. Subtracting 1 from here gives 1. This will be negative 1/3. Remember that was 1/3 of a half was 1/6. A half is 3/6, so we end up with 2/6 or 1/3 there. 0. 1/3 of 9 is 3. Subtracting that gives you 2. Row 4 already has 0 in its position in the Y column. Therefore, we simply need to put row 4 in again. 0, 0, 0, negative 5, 0, negative 2, 1, and 1. It says we need to now interpret our tableau. Well, the first thing to note is that these are all positive. So these are all values which are greater than 0. So therefore we have an optimal solution where the value of P is equal to 18. It's in the top row. Now we need to look at each of these other rows. The X column has got a 1 in row 3, which has got a value of 2. So this is X is equal to 2. The Y column has got a 1 in the second row, so Y is equal to 6. Z column, it has not got zeros and ones in it, so therefore Z is equal to 0. But the column which has 1 in here and zeros is the U column, and therefore that's the inequality which has still got some slack. So we've got therefore the slack variable in the U column. So if we go back to our initial equation, then that was 4z plus 2y plus 3z, which was less than or equal to 21, which has still got slack. And you'd need to get that from the initial part of the question. Right, okay, the marking here, well, they're similar to the first part, or part A of the question. There was a just a method mark for getting that particular pivot there. And then there were 3 marks for obtaining here, or up to 3 marks for doing the row operations. It's giving a total of 4. The interpretation, the fact that the optimal value is reached, scored 1 mark, and then a B mark for P, and B mark here for X, Y, and Z. These are actually follow-through marks, so if you'd made an error in your working, you would still get the marks for the interpretation. And a B mark for identifying the correct inequality there. And notice it's the inequality that we're asked for, the initial inequality. Okay, that's the end of this question. You can find solutions to other questions at www.furthermaths.org.uk.